For the past decade, performance-driven animation has been a reality in games and movies. While capturing and transferring emotions from human beings to avatars is a reasonably solved problem, it is accepted that humans express themselves in different ways, with personal styles, even when performing the same action. This paper proposes a method to extract the style of human beings' facial movements when expressing emotions in posed images. In order to do that, we first consider the topic of motion style. It includes two main concepts, content and style. The first represents a task that is performed with an objective purpose, while the latter describes how each individual performs such action. Thus, in our study, we consider the acted content to be the 6 basic human emotions, as defined by Paul Ekman, which are happiness, sadness, anger, fear, surprise, and disgust. And the style we consider to be the variations found when different individuals express the same emotion. Our main objectives with this study is to investigate whether the concept of emotion style exists and is identifiable by computational methods, and also to define a method to extract such style from a subject so that it can be represented parametrically and applied to virtual humans. Using 2 different datasets of posed images, we extracted the subject's facial expression intensities in order to cluster them in groups of similar styles of expressing a given emotion. We used the k-means and Gaussian mixture model methods, together with the Akaike and based information criteria to define the number of groups to be used in the clustering. The generated clusters are then evaluated qualitatively by visual inspection and quantitatively using the silhouette score metric and LCS distance between clusters. Once the clustering is complete, we use a 3D facial rig based on the facial action unit coding system to represent the styles found among the most well-evaluated clusterings for each emotion. With this resource available, we can transfer the action unit characteristics of a certain cluster directly to the rig, giving us a graphical generalization of the styles found for each emotion. Since our objective is not a one-to-one style transfer, but rather to summarize the facial expressions of each cluster into one generalization, we define 4 different operations to be applied on the cluster action unit data that is applied to the rig. These are the smooth operation, which transfers the mean intensity of the most frequent action units in the cluster, most frequent meaning the ones that were expressed by all subjects. The exaggerate operation, which increases the mean action unit intensity to be transferred to the model by a certain percentage, while not surpassing the highest intensity observed for each action unit in the cluster. Lastly, the simplify option, which considers only the n most representative subjects of the cluster when calculating the mean intensity, where the value of n can be defined by the user. In our experiments, we use the value of 3 subjects. In this slide, we can see the results obtained for this expression synthesizing method for our happiness clusters obtained using Gaussian mixture models. The results obtained for the other emotions are available in the full paper. We also conducted a public survey in order to determine which of these operations are more appropriate for the generalization of emotion styles in a virtual character according to human perception. Participants were asked to evaluate the similarity between the generated facial expressions and the cluster that they attempt to represent. In this slide, we show the results obtained when clustering the happiness emotion using Gaussian mixture models. On the right, we can see a graph of the average intensity of the most frequent action units in each cluster, accompanied by their 2 most representative subjects and the generalization of their styles applied to a virtual human. On the left, we show the results from our quantitative evaluation, which in this example yielded satisfactory results. In general, we were able to find visual similarities between members of the same clusters, as well as visual differences between members of different clusters. Our validation of the clusterings also indicates that the results make sense, but are clearly affected by the intersection between emotions. Regarding our public survey, looking at the graph on the right, we can see that exaggerate 50% method got the most vote, while smooth was the least chosen. This could indicate that only using the mean action unit intensity is not enough to successfully represent an emotion style, but when we exaggerate these values, the similarity between the 3D model and the cluster subject can become more evident. Also, the fact that the none option held a high score shows that our method still needs improvement, since these results mean that none of the provided options were satisfactory to the participants in a significant number of questions. Please check our full paper for further analysis of our clusterings, survey results, and further experiments that we executed in this paper.